My name is Jeff Passmore. I work for Viavi sales support organization. I will be your host on a continuing series of copper testing videos using the new ONX 580 test platform. Today's session will be a continuation on our discussion of time domain reflectometer, or TDR, which will be discussing TDR use in the standard mode of operation. During this presentation, we'll discover how to set the velocity of propagation, or speed limit as I like to call it, how to use the distance cursor, innovative modes such as peak and stress, setting a test reference, and saving test results. So with that, let's move over to the ONX. For the sake of this presentation, we'll assume that you were able to watch our opening video where we discussed theory of operation for the TDR and also basic navigation once you're inside the device. If you haven't watched that, please do. It'll help you as we go through today's session. So across the bottom edge of the TDR screen, there are 4 soft icons or soft buttons, however you would like to refer to them. The first is labeled Mode, the second Options, the third Reference, and the fourth is simply our Start-Stop button. You can select the mode by either touching it or using the key right underneath it. And if you've selected mode, please ensure that the radio button is next to Standard TDR, because that's what we're going to be talking about today. A good habit to develop is always making sure that the velocity of propagation or speed limit is correct for the cable being tested. To set the speed, you would select under the Options soft key, Cable Type. That would bring up a pop-up that displayed both the cable fill type and cable gauge. As with all of our navigational options or features on the ONX, a particular feature is active when a purple highlight bar surrounds it. So as you can see here, cable fill type is active. I can use my left or right arrow keys or my finger to cycle between air core, jelly, pulp or paper, and even a custom setting for custom velocity of propagation. Now to change gauge, I simply touch in the area of gauge, move my blue highlight bar down to it, and use again my left or right arrow keys to select between 19, 22, 24, 26, or mixed if you're in a mixed gauge environment. Once you're satisfied with your selection, press the OK button to lock that speed into the TDR. Considerable development work into not only innovative features for the ONX TDR, but also ease of use. If you recall from our opening session, the ease of use is very straightforward using quick range. So once we've connected up to the cable pair that we want to test, we just simply walk our way out the cable pair by increasing the plus sign on quick range. Quick range automatically controls the gain and the range of the TDR. Simply keep hitting the plus sign until the event or reflection is viewable on screen. In the TDR cursor trace area, one innovative feature is the XY graphs, or the distance markers along the bottom edge of the screen. This gives the user a rough idea of the distance to the displayed reflection events. For example, my first event looks like a lowering of impedance at roughly 1,000 feet. The second event is an increase in impedance that's a little less than 2,000 feet. So with just a glance, I get an idea of where these events are. Now, of course, I can still move the distance cursor and line them up on the event to get the exact distance to fault. The fastest way to move the cursor is just by dragging it with your index finger and lining it up on the fault. Lining up on the fault, the cursor should be placed where the horizontal line changes from horizontal to vertical in either direction, up or down. You will see at the top of the cursor the label mark, and above that the footage, or the distance the cursor is away from the tester. This particular event is 961 feet away. Now, often you will be presented with multiple reflections on the screen, and it will be to your benefit to know the distance to each of those reflections. For example, we have a lowering of impedance followed by an increase in impedance. Quite often, it's also helpful to even get the distance between the two events. Well, this is where mark comes in. By pressing the OK key, I place a mark or a temporary cursor at wherever I have the cursor placed currently. That allows me to drag my primary cursor over to the second event. And now I have the distance to the second event of 1,937 feet, but a delta, or distance between the two events, of 975 feet. Now, removing the mark cursor is just as easy as applying it. Simply press the OK key, and you're back left with only the live or active cursor. When we spoke of the strengths of the TDR, one of the things that we mentioned was its ability to open locate. Now, the term open in telco is kind of a catch-all phrase, right? It can mean a double-sided open, both conductors broken, single-sided open, only one, or a partial break, often called a high resistance open or a dirty open. Now, the dirty open or high resistance open is particularly troubling because at times it will appear to be fine. But with temperature and movement, the line will begin to break, or the conductor will actually begin to break. Well, all of this change or dynamic change results in a negative customer experience. So locating these high resistance opens becomes a pretty high priority. Well, one feature added to the ONX 580 to aid you in that is found under the Options tab, and it's labeled Stress. What stress does is stop the TDR momentarily and apply 120 volt DC source to the line. Now, the DC source is a dual polarity source and a current limited one, meaning that it cannot hurt you or any electronic equipment that you may be measuring into or have on the line. The thought being is that the jolt of 120 volts might unsettle the line enough for you to catch a difference in the trace, because after the 120 volts has been applied for a few seconds, the TDR is turned right back on again. Well, to aid you in capturing that change in trace is the second half of this feature, and it's called peak mode. Technicians think that TDRs run in a continuous fashion. Well, actually, they run in a pulsing fashion. When the TDR is first turned on, the sequence of events goes send the pulse, receive the reflection, and draw the picture. Well, every subsequent pulse after that, the sequence is a little bit different in that it's send the pulse, receive the reflection, erase the previous picture, and draw a new one. Well, what peak does is never erase. So its sequence is send, receive, draw, over and over again. The reason for this is it's unbelievably easier for your eye to catch a difference in a line if it's being written over atop itself, as opposed to a new or fresh line given each and every time. This is clearly depicted on the screen with the blue portion of the trace being what we were looking at before applying the stress signal, and the orange, what we're looking at now live after the stress signal of 120 volts has been applied. Clearly the jolt of voltage has introduced a high resistance open. Now this one is very clear. You can see it very clearly on the screen, but others will be much more subtle. So the line will just maybe appear to get thicker in a location. So if I was actually working on this case of trouble, I would place my cursor on that first bump about 1,437 feet away, and that's where I would begin my investigation. Now to remove peak, just go to Options and touch peak hold to turn the feature off, and you will be back where you started from. Having taught on TDR instruction for several years, one of the things that I like to tell technicians is a lot of times uh, comparison is your strongest tool with the TDR. And I even say that sometimes finding out where the trouble is not is just as important as finding out where the trouble is. Now, that sounds a little peculiar, but for example, a great method of comparison is to compare your faulted pair to a known unfaulted pair. Right? Another method of comparison would be a little bit more sophisticated, would be comparing your pair 1 and pair 2 of your bonded DSL service to make sure they were symmetrical or looked the same. Well, the comparison feature on the ONX is found under soft key number 3, labeled Reference. If I select Reference, I have an option to set a reference. When I select that option, the current trace is frozen on the screen. That allows me to disconnect from the cable pair I was measuring and move over to a cable pair for comparison, whether it be my second pair of the DSL bonded service or just another customer's line that's not in trouble. The difference between the two are easily distinguishable. Right? Now, the green is the pair that I started with, right? And the orange line is the pair that I moved to. So again, we can see a significant difference between the two pairs. And I would place my cursor at the start of where the green starts to rise up there vertical. And I would begin my search for problems at 1,447 feet. Now, while set reference is a great real-time tool to use to quickly compare pairs to other pairs or bonded DSL, as I said earlier, there's another need to save a test result, and that being if you wanted a historical reference. So underneath reference again, there is the option to save a result. So I'll simply select that option, save. A pop-up menu will come up that will allow you to name the test. So let's just type in test as an example. We press OK. Now that particular image or reflection is saved in the ONX memory. Well, it can now be recalled at a later date by going Reference, Load, and selecting the test.xml file. That loads the historical trace and lets you compare it to a trace that you are currently looking at. And again, the original is depicted in green. The actual is depicted in orange. So we can see quite a difference between the two pairs there. So two different ways to compare, one more of a real-time function, the other more of a historical thing if you wanted to save it over a period of time. Well, that concludes our session today on the standard TDR operation. We hope you enjoyed it, and we certainly thank you for your time. Please join us again for future sessions where we'll discuss some more of the TDR modes. We'll also be discussing RFL, resist default locate, and spectral analysis. So please try to join us, and thank you again for your time.